Hi, today I will be describing the function of different types of registers for learning target 10A. So the way I will be showing this is I made a parallel and serial register and combined them together to make a multifunctional register. I did this by using four 4-to-1 muxes. We have mux 0 all the way to mux 3. Each mux is routed to a D flip-flop, D0 to D3. Here on the left here, we have our left shift, our right shift, our parallel loader option, and our mode toggler. We have a hexadecimal display for easy readability, and we have our clear and our clock, and enable switch. This is our clear, but I just rerouted the wire over here, so it's easier to access. So to explain the P loader, the parallel shifter, the most significant bit is routed to the most significant bit in the mux. So our D3 over here, the most significant for our 4-to-1 mux, is I3, and that gets routed. I2 gets routed to D3, I1 to D3. So each value of the parallel loader gets routed to the most significant bit in our mux. Now let's go test out its functionality. So to enable our parallel loader, it will be value number 3. And let's take this off. And on the next positive clock pulse, our register will shift values to 7. Now let's try it for every other value. We can do D. Takes a little time, but the register does change. We have 8, 4, and so on. Now to go to our left shift. The left shift works by moving every binary digit to the left, so it goes from the least significant bit to the most significant bit. So let's clear our values right now. Let's lower the clock so we can see how the values are working. So to enable our left shift, it is option number 1. Option number 2, I mean. It's a little laggy. Now we have our left shift. Now if you want, we're going to shift this to 1 so we can see the value shifting. And we're going to take off this clear so we can see it in action. So it's going to go from our least significant bit to our most significant bit. And we can actually speed this up just a little bit. As you see here, the values are shifting to the left by 1. Now as soon as we toggle this and say we want it to shift with a value of 0 in the register, 0 will start outputting. And over here we can see our mux taking place too. Let's go see it in action. And we can put a 1 here. And you can actually see the values shifting by 1. Now if we shift it to 0, we can see the mux just changing. As you see, 0 goes down for our D2. Let's go watch that one more time. You can see there, value of 1 gets put in, D2 switches. There we go. Now for our right shift, it's the opposite. Instead of going from the least significant bit to the most, it goes from the most significant bit to the least significant bit. Now to enable this option, we will click the value of 1. I'm going to reset first, clear our values, toggle on 1, and to see this take place, we'll be using 1s. And let me activate the circuit again, and we can see that it will start from the top and go to the bottom. As you see here, the 1s are replacing, and it's shifting all the values down from the most to the least. Now we can enter in a 0. And the same thing takes place. A 0 will now be filling in the options. And we can keep doing this. There we go. Now I am going to see here, we have our right shift, and we're going to go see this live. We're going to input a value of 0, and over here our right shift will switch. As you see here, D1 will get filled with a 0. Then our D1 flips, and you can see the register is changing. And also when those are changing, our D flip-flops are changing too. So let's go see that one more time. We can set this value to 1. The 1 will take place, and it'll fill in over here for our right shift at D1, and every D1 value will switch to a 1 simultaneously with our D flip-flop. So let's see this live in action. Our 1 gets filled, D1 gets filled, D1 gets filled, D1 gets filled. And as you see, all the values of Q0 to Q3 change too. And that is my display of a multifunctional register showcasing a parallel and a serial shifter.